But the answer will surprise you: dinosaurs were not all mindless giants. For epochs, these creatures dominated every terrestrial niche. But what was happening inside their massive heads? A paleontologist studies endocasts, impressions left by the brain. But these molds reveal structure, size, and relative proportion. I'll consider the enormous long-necked sauropods, such as massive plant eaters. Their body mass dwarfed their cranial capacity immensely. This disparity leads us to the encephalization quotient, or EQ. An EQ measures deviation from the average reptile baseline. Most large herbivorous dinosaurs registered very low EQ scores. This implies basic instinctive behaviors govern their lives. Now that we understand the largest dinosaurs, let's explore smaller predators. The theropods, or meat eaters, show fascinating neurological variances. But their large olfactory bulbs suggest highly developed senses of smell. A smell was crucial for locating food and navigating territory. The visual processing centers also show signs of complexity. Some smaller theropods possessed EQ scores approaching modern birds. But this suggests enhanced spatial awareness and reactive planning skills. But these were not merely walking stomachs, their complexity was present. The most intriguing examples come from the dromaeosaurids. But their keen eyes and balanced posture hint at high coordination. Fossil evidence indicates surprisingly developed cerebellum regions. The cerebellum manages movement, balance, and potentially learned skills. But this strongly suggests cooperative hunting strategies were employed. We can draw parallels with their avian descendants today. Birds inherited traits that required significant neural organization. Evidence of extended parental care also implies intelligence. Protecting offspring requires recognizing threats and maintaining vigilance. But not all dinosaurs were neurologically advanced thinkers. The largest apex predators often favored sheer power over nuance. Their endocasts, while large, were proportionally smaller relative to their bodies. A brain structure suggests dominance through instinct and overwhelming sensory input. We must consider the evolutionary pressures of their specific environments. Quick, agile hunters needed fast reaction times, not deep contemplation. Their semicircular canals, visible in the inner ear bones, were complex. And this facilitated the incredible speed and balance needed for pursuit. Intelligence isn't just problem solving, it's memory and habit formation. The social complexity is a strong indicator of cognitive depth. Or did they communicate beyond simple threat displays or calls? The cranial structures suggest pathways for more nuanced interaction. The integration of sight, sound, and scent was paramount for survival. This required faster cognitive mapping than previously assumed. Some small Mesozoic mammals had surprisingly high EQ scores. This highlights that intelligence isn't solely correlated with size. Ecological niche dictated the necessary level of neural development. Solving spatial problems was vital for finding hidden resources. A persistence in excavation requires sustained focus and drive. But learning from repeated successful actions builds complex behavioral patterns. But even ritualized combat requires assessing opponent's strength and timing. But precise timing is more important than brute kinetic energy alone. The Mesozoic world demanded specialized intelligence for diverse survival. From herd dynamics to individual cunning, cognition mattered. And the ability to hear complex sounds also implies social structure. Different frequencies conveyed danger or social recognition signals. Our understanding continues to evolve as new techniques emerge. An advanced scanning technology reveals internal structures previously hidden. We are seeing intelligence in degrees, not just absolute terms. The smaller, more agile dinosaurs often exhibited higher EQ values. Their cognitive landscape was as diverse as their physical forms. But these ancient minds shaped a world, proving intelligence takes many forms.